In this video, we're going to do an overview of the computing tools we'll be using in this course. All of the homework assignments and the lecture demos will be done via Jupyter Notebooks. And we'll be accessing it via the Jupyter Hub that you can get on the website coding.csel.io. So let's actually go to that website here and give you a peek. This is what it looks like. This is an example of a notebook we'll be reviewing in some upcoming videos. But what's nice about Jupyter Notebooks is they combine both code as well as text. You can also write math equations and you can add in visuals as well. Also, what's nice about the Jupyter Hub interface is when we're working with data, which we often will, you can actually take a peek directly at the raw data file, like we have here, before you load it in and manipulate it in the notebook. Since we'll be using Jupyter Notebooks throughout this course, I just wanted to give a shout out to one of its creators. Fernando Perez was actually a graduate student in the early 2000s at CU in the physics department. And on the side, while a graduate student here, created IPython along with his friend Brian Granger. And that development led to things including Project Jupyter. Fernando is now a faculty director at the Berkeley Institute for Data Science. But I thought it was a fun connection since he actually started a lot of that work while he was a graduate student. A big piece of this course is going to be analyzing tabular data. And by that, I mean data in a table. Typically, it's going to have the following format, where a row is representing one record of data. In this example, this is actually data from US elections. And here, a single person running for president in a particular year is what's represented in a given row. Columns typically represent some characteristic or feature. In this example, the column I have highlighted is the political party. Pandas is the library in Python that was designed specifically for working with tabular data, and that's what we'll be using throughout this course. So Pandas was built basically on a lot of the coding idioms from NumPy, and we'll talk about NumPy in a minute. But the biggest difference is Pandas is really designed for working with this tabular data. Using Pandas, we're going to be able to do a lot of our data analysis and a lot of our cleaning and wrangling of the data. So we'll be extracting useful information, we'll be making plots, we'll be operating on data, and it's especially useful because it can perform what are called vectorized computations, which we'll see an example of in a bit. So this first week of the course is basically going to be a boot camp with some of the key functionality items we'll be using in Pandas. And then throughout the rest of the course, you'll be continuing to build your knowledge of Pandas as we use it for different applications. This is a great resource for diving deeper into anything that we don't cover in these lessons. It is open access, and so you can access it directly at this link. In addition to Pandas, we will be using the Python library NumPy, which is a data analysis library that is designed specifically for scientific computing. In particular, it includes functions for fast operations on entire arrays of data, which eliminates the need to have to write loops and uses far less memory. In your first homework, we'll be going through a basic tutorial of some of the key features of NumPy. So this was a quick overview of the key tools we'll be using in the course, and we will be diving deeper into each of these tools throughout the course.